There is a hole in the sun, and it is pointed directly at Earth right now. I have been monitoring solar activity for years, and what NOAA's Space Weather Prediction Center confirmed in the last 24 hours stopped me mid sentence. A high speed solar wind stream launched from a coronal hole facing Earth sun line is expected to arrive at our magnetosphere beginning April 15th. That is today. The G1 Geomagnetic Storm Watch window runs through April 17th. And the Aurora Oval, the ring of glowing sky that only appears when the sun hits us hard enough, is forecast to descend as far south as Seattle, Washington, as far south as Edinburgh, Scotland, as far south as the northern tier of the continental United States, and across large swaths of northern Europe. People in those cities do not see the aurora, not normally, not unless something significant is hitting us. And right now, something significant is hitting us. So let me break down exactly what is happening, what the data shows, what the history tells us, and most importantly, what you need to know and do in the next 48 hours. Stay with me, because what comes next changes everything. Let me start at the source, literally the sun, because to understand why this matters, you need to understand what a coronal hole actually is, and most science coverage gets this completely wrong. They call it a hole in the sun, like something is missing, like the sun is broken. That is not quite right. A coronal hole is a region in the sun's outer atmosphere, the corona, where the magnetic field lines do something unusual. Normally, the sun's magnetic field loops back on itself, like a closed circuit. Plasma travels up, arcs over, comes back down, contained, controlled. But in a coronal hole, those field lines open up. They don't loop back. They shoot outward into space like an open fire hose. And the solar wind, that constant stream of charged particles the sun is always broadcasting in every direction, accelerates dramatically through those open channels. Think of it like this. Normal solar wind is like water flowing through a garden hose at medium pressure. Coronal hole solar wind is like someone removed the nozzle restriction and cranked the tap all the way open. The particles come faster, they hit harder, and when they arrive at Earth, they compress our magnetosphere, the invisible magnetic shield protecting everything alive on this planet, like a fist squeezing a balloon. That compression is a geomagnetic storm, and right now, NOAA is watching one arrive. As I am recording this right now, the solar wind speed upstream of Earth, measured by the DSCOVR satellite sitting at the L1 Lagrange point, about 1.5 million kilometers sunward, is already beginning to show the precursor signatures. The B's component of the interplanetary magnetic field, the single most important number in space weather, is the key variable I am watching, and I will explain exactly why in a moment. But first, let me show you the coronal hole itself, because the images coming out of NASA's Solar Dynamics Observatory in the last 48 hours are remarkable. The SDO images the sun continuously in multiple wavelengths, in extreme ultraviolet, wavelengths invisible to human eyes. Coronal holes appear as dark regions against the bright solar corona. Dark because they are less dense. Dark because the plasma is escaping outward instead of being held in a closed loop. The coronal hole currently facing Earth is a mid to high latitude southern hemisphere feature. It is not the largest coronal hole I have ever tracked, but its geometry is almost perfect for Earth impact. It is facing us almost directly. And solar wind does not travel in a perfectly straight line from source to target. It sweeps across a wide angular arc as the sun rotates. This one is sweeping directly across the Earth-Sun line right now in the next 24 hours. But that is not even the real story here. The real story is the timing and what else is happening on the sun right now simultaneously. Because we are not just dealing with one coronal hole. As of the most recent SDO imagery and NOAA solar region maps, there are multiple active regions on the solar disk. We are currently in solar cycle 25, and solar cycle 25 has dramatically outperformed predictions. The official NOAA and NASA forecast panel, the solar cycle 25 prediction panel, projected a moderate cycle. Modest sunspot numbers, Modest activity. What we actually got was something else entirely. Solar cycle 25 has been running significantly above the predicted smooth sunspot numbers since 2023. It hit its predicted maximum earlier than forecast. And now, in 2026, instead of the expected gradual decline, activity is stubbornly, persistently elevated. This is important because elevated solar cycle activity means more active regions. More active regions mean more potential for flares, more potential for coronal mass ejections, more coronal holes rotating into Earth-facing geometry, and more events like the one arriving today. I predicted this elevated cycle behavior in a video I posted in early 2024. I said the panel was underestimating cycle 25. I said we would see more geomagnetic storms than the official forecast suggested. That prediction held. And right now, everything I said then is playing out in real time. Now here is where it gets interesting. Let me explain why the BZ component I mentioned earlier is the single most important number in space weather. Because understanding Bs is the difference between a G1 storm and a catastrophic G4 or G5 event. The B is the north-south orientation of the interplanetary magnetic field carried by the solar wind. When Bs points north, in the same direction as Earth's own magnetic field at the equatorial plane, our magnetosphere deflects it efficiently. The solar wind flows around us. We barely notice. But when Bs turn south, anti-parallel to Earth's field, something called magnetic reconnection occurs. The solar wind's field lines and Earth's field lines essentially grab each other at the day side of the magnetosphere. They merge. They open a direct channel, and energy that was flowing around us suddenly pours in. This is like a castle's drawbridge dropping unexpectedly. The normally locked gate swings open, and the storm intensity depends almost entirely on how far south Bs goes and how long it stays there. During the May 2024 G1Storm, the most powerful geomagnetic event in 2 decades, a G5 event, Bs plunged to negative 60 nanoteslas and stayed there for hours. The Aurora was visible in Florida, in Texas, in northern Mexico, in parts of northern Africa. Power grid operators across North America went on emergency alert. Satellite operators had to make emergency adjustments. GPS accuracy was degraded for hours across multiple continents. Now, I want to be absolutely clear. The current event is not the G1Storm. This is a G1 watch, moderate, but I find it very interesting that the conditions priming this event share some structural similarities with the buildup pattern we saw before larger events. I am not saying this escalates, but I am watching the BZ with every model update. And so should you. Stay with me because what comes next changes everything. Let me talk about what a G1 storm actually does and does not do, because the information space on this topic is full of both dismissiveness and overclaiming, and you deserve accuracy. A G1 geomagnetic storm on NOAA's 5-level KP scale corresponding to KP values of 5 is classified as minor. That is the official language. And in terms of catastrophic infrastructure risk, that classification is appropriate. Your power grid is not going to fail. Your phone is not going to stop working. Satellites will experience minor drag increases and potential orientation perturbations, manageable, known, handled routinely by satellite operators. HF radio communications, particularly at high latitudes, may experience some degradation. Migratory birds that navigate using Earth's magnetic field, and there is genuinely fascinating peer-reviewed science on this, may experience some navigational disruption. But here is what a G1 does do. It brings the Aurora, not to Iceland, not just to northern Norway and Tromsø and Svalbard, to places that almost never see it. The KP index is a global measure of geomagnetic disturbance. At KP5, the G1 threshold, the Aurora oval expands equatorward to roughly 50 to 55 degrees geomagnetic latitude. Seattle sits at approximately 50 degrees geographic latitude. Edinburgh is at nearly 56 degrees geographic latitude. Portland, Oregon, Calgary, Alberta, Dublin, Ireland, Parts of central Germany, Warsaw, Poland, Minsk, Belarus, these are all in play for at least a glimpse of Aurora during the peak window. And if the storm strengthens, if B's cooperates and drives us toward G2 or briefly G3, the oval pushes further to Denver, to London, to Paris, to Amsterdam. I am not saying it will reach those cities, but the setup exists for it to try. What I am about to show you next, most people have no idea about, and this is the part that absolutely floors me every time I explain it. The auroral light you see in the sky, those ribbons and curtains of green and red and purple, are not just beautiful. They are a visual display of physics happening 100 to 300 kilometers above your head. Charged particles, mostly electrons and protons, are accelerated down magnetic field lines into Earth's upper atmosphere. They collide with oxygen and nitrogen atoms. Those atoms get excited. Electrons jump to higher energy states. And when they relax back down, they release that extra energy as photons, as light. Green aurora, the most common, comes from oxygen at around 100 to 150 kilometers altitude. Red aurora, rarer, more spectacular, seen during stronger storms, comes from oxygen at higher altitudes, above 200 kilometers. Blue and purple aurora comes from nitrogen. And during significant events, all three layers can activate simultaneously. The sky turns into a living, moving painting of physics. It is one of the most extraordinary things a human being can witness. And for people in Seattle and Edinburgh tonight and tomorrow night, for the first time possibly in years, that experience is within reach. But here is the practical part. Because knowing aurora is possible and actually seeing it are two completely different things. Light pollution is the enemy. City centers will wash out fainter displays. You want elevation if possible. You want a clear northern horizon, unobstructed by buildings or trees. You want to get away from urban cores. Even 30 minutes of driving away from a city center can transform a barely visible haze into a clear curtain of color. The peak window based on current solar wind propagation modeling is April 15th overnight into the early hours of April 16th, with a secondary enhancement possible April 16th to 17th if the solar wind stream has a trailing high-density component. This is a two-night window. Do not give up if night one is cloudy. Track the KP index in real time. NOAA's Space Weather Prediction Center updates it every 3 hours and every 1 minute. The Space Weather app, the Aurora Watch UK alerts for British viewers, the Space Weather Live website. These are your tools. Bookmark them right now. But that is not even the real story here. Let me zoom out because I have been thinking about something and I want to share it with you. We are living through a genuinely extraordinary period of solar activity, and most people have absolutely no idea. Let me give you some historical context. The Carrington event of September 1859 was the most powerful geomagnetic storm in recorded history. A coronal mass ejection hit Earth with such force that telegraph systems, the entire global communications infrastructure of the era, caught fire. Operators received electrical shocks through their equipment. Aurora was visible as far south as the Caribbean, as far south as Rome and Havana. People in the northeastern United States woke up thinking it was dawn at 1 in the morning because the sky was so bright. That event, classified in hindsight, would have been a KP of somewhere around 9+ on the modern scale. Off the charts. Now, we do not have a Carrington-level event happening today, not even close. But here is what I find genuinely sobering. A 2012 study published in the journal Space Weather estimated that if the Carrington event hit Earth today, the economic damage could reach between $0.6 and $2.6 trillion in the United States alone. Power outages lasting weeks to months in some regions, satellite losses, GPS disruption, communication blackouts, and in 2012, literally 2012, a CME of near Carrington magnitude erupted from the sun. It missed Earth by 9 days. 9 days. If Earth had been in that orbital position 9 days earlier, we would have taken a direct hit. The trajectory was confirmed by stereo spacecraft that were watching from the side. We missed it by 9 days. I am not saying that to frighten you. I am saying it because it is true and because it illustrates something critical. The sun is not a friendly campfire we are warming our hands next to. It is a 400,000 kilometer wide ball of magnetically violent plasma that periodically erupts with the energy of a billion hydrogen bombs, and we live around it. We depend on it, and we have built an entire civilization, satellites, power grids, communication networks, financial systems that is exquisitely sensitive to what it does. Understanding space weather is not a niche scientific hobby, it is civilizational risk management. Now, here is where it gets interesting. Because in the last 5 years, and particularly in the last 18 months, space weather preparedness has become a serious policy priority in a way it simply was not before. In October 2024, FEMA updated its National Space Weather Strategy. In early 2025, the United Kingdom's Space Weather Preparedness Strategy was revised to include critical infrastructure protection guidelines for scenarios up to and including extreme events, the X category above G5. The European Space Agency's Space Safety Program has been expanding its solar monitoring network. And the reason this is happening right now in this specific window is directly linked to solar cycle 25 outperforming expectations. The governments and agencies that track these things know that elevated solar activity increases the probability of a significant event, and they are quietly, without alarming the public, putting preparations in place. This is the part they are not showing you on the evening news, because government agencies quietly preparing space weather contingency plans does not fit into a 2-minute broadcast segment. But it is happening, and I think you should know. Stay with me. Because the final piece of this, the most personal piece, is what I want to leave you with. Let me talk about May 10th, 2024, because I was right here tracking the data, watching the KP index climb when the G1Storm hit. It came from a sequence of X-class flares from active region 13664, multiple CMEs piling into each other. A phenomenon called a CME cannibal event, where faster ejecta catches and merges with slower ejecta ahead of it. The merged structure hit Earth's magnetosphere, and the KP index went to 9, then to 9 plus, a G5, the highest category, the first G5 since the Halloween storms of 2003. And the Aurora was visible in places that had not seen it in living memory: Puerto Rico, the Yucatan Peninsula, the Saharan Atlas Mountains of Algeria, the Atacama Desert in Chile. I posted about it here before almost anyone else in this space was covering it, and the response from this community was overwhelming. Thousands of you went outside that night. Thousands of you saw the aurora for the first time in your lives. I still get messages about it. I drove 40 minutes outside my city and I cried. I saw it from my backyard in Tennessee and I could not believe it was real. My kids will never forget this. That is why I do this. Not for the data, not for the models, for the moment when the science becomes an experience, when an abstract number on a screen becomes a curtain of green fire over your neighborhood. And right now, tonight and tomorrow night, that possibility exists again for people in Seattle, in Edinburgh, in Calgary, in Minsk, in Dublin. Maybe even further south if the bees cooperates. This is a real window. It is not guaranteed. Aurora watching never is. But the setup is there. And the people who go outside and look, the people who drove away from city lights and tilted their heads north, they are the ones who get to have that moment. The ones who did not know, the ones who are not watching. They will wake up the next morning and see the photos on social media and feel that pang. I missed it. Do not miss it. Now let me give you the action list, because I am not here just to inform you. I am here to make sure you can actually act on what I tell you. 1. Download a real-time KP monitoring app before tonight. Space Weather Live, My Aurora Forecast, or the NOAA Space Weather app. Set alerts for KP5 and above. 2. Identify your dark sky location right now. Before tonight, before tomorrow night. Know where you are going, know how to get there. Have it ready. 3. Face north. Aurora in mid-latitude locations is not directly overhead. It sits on the northern horizon, sometimes low, sometimes you have to look very carefully. Your eyes need 20 minutes to dark adapt. Do not check your phone for 20 minutes after you arrive. Let your eyes adjust fully. 4. Use your camera. Modern smartphones, particularly newer iPhone and Android models, are dramatically more sensitive to aurora than human eyes at low intensities. Even if you think you cannot see it, take a 30-second exposure pointed north. What your camera sees may surprise you. 5. Watch the April 16th to 17th window as well. Trailing solar wind streams can produce secondary enhancements 12 to 24 hours after the initial impact. The party is not necessarily over after night 1. As I am recording this right now, the latest model runs are still being processed. The DSCOVR upstream data will tell us a great deal more in the next 6 to 12 hours about the actual BZ behavior we can expect. I will be watching every update, every data point, every model revision. And if something changes, if this strengthens, if a surprise CME enters the picture, if the bees plunges and this becomes something bigger, I will be back here immediately. That is my commitment to you. Early warning. Every time. Now, the sun has been putting on a show for billions of years, long before humans walked this earth, long before anyone was looking up with satellites and magnetometers and SDO imagery. Those photons have been flying across 93 million miles of space, landing on Earth's atmosphere, lighting up the sky since before our species existed. And tonight, or tomorrow night, a few thousand of you watching this right now are going to go outside. You are going to drive away from the city. You are going to stand in a dark field or on a hillside, and you are going to look north. And if the bees cooperates, if the cloud cover breaks, if the timing aligns, you are going to see something ancient and enormous and beautiful, the sun reaching out across 93 million miles and touching Earth's atmosphere with light. That is not just science. That is one of the most profound experiences this planet has to offer. And the only difference between the people who have that experience and the people who miss it is knowing it is coming. You know, so go. If you are not already subscribed, please do it now. Not because I want the number, because the next event in this solar cycle will not send you a calendar invite. It will not wait for a convenient moment. The sun does not negotiate with our schedules. The only way to not miss the next one, and there will be a next one, possibly larger, is to be part of this community where I am watching so you do not have to watch alone. And I will tell you everything you need to know the moment I know it. In the next video, I'm going to go deep on something that genuinely unsettled me when I first worked through the numbers. It involves solar cycle 25's declining phase and what the historical record says about what kinds of events tend to happen as active cycles wind down. The answer is not what you expect. It is not what most people in this space are talking about, and you are going to want to see it. Get outside tonight. Look north. I will see you in the next one.